I'm Ryan Nichols, CTO at DSA Ocean, and today I want to talk about how you can quickly make a time series comparison of ship motion performance with and without an anti-roll technology. So for this example, what we're going to do is use the 50-meter generic yacht. So here it is, the bare hull version with no fin stabilizers. We're going to generate a time series of data using the ProteusDS ShipMo3D toolset application time series from RAO. And then we're going to make another data set, another time series with fin stabilizers on in the same sea state, and we're going to put it into Excel to make this nice kind of before and after kind of comparison time series. So I'm just going to show you the process of going through that. So this is the generic yacht figure from BuildShip, and as I said, you can see that there's no fin stabilizers on there. So this BuildShip version I've got named bare hull, and then if we go to Seakeep regular, I've also called this one bare hull just to keep things kind of organized here a little bit. You can see I've got the bare hull file for that, and we're going to be calculating 0 and 12 knots and a wide range of frequencies, but just beam C. So we'll run that, and then the motion RAO itself, you see you have like at 0 speed, you got like kind of quite a peaky RAO. At 12 knots, it's also quite peaky, and there's not a lot of roll damping going on there. So to use this application time series from RAO, if you don't have it already, you got to go add new data and time series from RAO. The way it works is pretty simple. You specify a seaway, and then also you need to specify the motion RAO file. So you can see this one that I've just generated here, the bare hull from Seakeep regular database. So we'll add that. Now we need to make a seaway as well, and you do this with the build seaway application. Again, if you don't have it in your project, you got to go add new data and build seaway. I'm just picking something kind of arbitrary, sort of like, not a nice day, but something appropriate for yachts, 1.5 meter significant wave height, 7 seconds. Now you do want to consider the direction here, because it's going to make one sea state kind of thing, not a range of stuff together. Just for simplicity, I've got this coming from 90 degrees for a beam C condition. You put in the ship heading in time series from RAO. So it's just going to be, ship heading is going to be pointing 0 north in that kind of case. So we run that, and we get a little XML file for the seaway. And you can see it right here, generic yacht John swap test. That's what I was calling it up here. And then we're ready to go. So what I want to do is for my bare hull, I want to be going 12 knots just to get a comparison for the forward speed condition for the fin stabilizers. Ship heading 0 degrees. So remember, we've got waves coming from 90 degrees. You get a nice beam C condition. The X and the Y position don't matter. We're going to get a lot of data, so we'll just do like, this might be overkill, but maybe we'll cut it back a bit and just do 500 seconds. So do 0 to 500 seconds, and we'll run this, and it's already done. So we open the, in our project folder, now you'll see this new file output, generic yacht time series from raos.out. So if you look at it here, we've got all the data here. So what I'm going to do is just select all that in my text editor here. We'll go copy, Control C to copy that. Let's open Excel, start with a blank workbook here. And maybe just for my own organization, just call this worksheet bare hull. So hit Control V, paste it all in there. Now it's not in columns or anything like that. So the first thing you have to do is go convert text to table, and we'll click on delimited, and we want spaces, right? So it's going to treat all spaces as column values. And now we've got it formatted in some columns here that we can use for making a chart. So we'll hit plus here, and then we're going to call this one fins. And I'll just put this to the side for the moment, and we'll close this file. Okay, so now we need to generate the time series with fins on it. So I'm gonna load up my fin configuration. So we're gonna exclude build ship here, and we're gonna go add existing data. And I've got build ship configurations under generic stabilization. So this is like 3 meter square area fins. We'll run this and just look at the plot ship version of this. So you can see we've got the fins. It's a little bit more forward. Yeah, that's just what we're using for this demonstration case here. So we run build ship already, and we'll go to ckeep regular. Now what I need to do is pick the build ship output file for the fin configuration, which I've got here, and we've got the same conditions as before that we used for the bare hull. So we'll run that, and when we look at the motion RAO, we see something kind of similar for maybe a little bit of roll damping at 0, but like there's no 0 speed function on right now for that. It's just forward speed. So when we go to 12 knots, we see the roll error is way lower compared to the bare hull, and we're getting sort of decent stabilizer behavior there. So now everything else is pretty much the same. Time series from RAO. Now we keep the Seaway file name, but we'll go into Motion RAO database file. And let's go back to ckeep regular. I overwrote the one that I made for bare hull. So let's just call this with fins. And we'll rerun that so I don't get confused. Okay, time series from RAO, motion database file. There we are with fins. Now here's the one trick I wanted to highlight. For the time parameters, instead of doing 0 and 500, what I'm gonna do is go 500 to 1,000. And then it's going to kind of do this before and after thing really quickly and easily when we plot the data in Excel. So we go save and run. Now when I look at the time series from RAO output file in my text editor here, you can see it's starting from 500 seconds. So we'll just go down to the bottom here and hit Control C. And under this new worksheet here, we'll paste it. Now it seems to pick up that it's similar format to the other stuff we already copied, which is good. So what we'll do now is we'll hit this, select this first column, and Control Shift down arrow will get all of that data. And we're gonna make a chart, create chart. And we want to do a scatter with the trend line like this. And we've got everything plotted here, all the motions. So what we want to do is click on this filter icon here, and we'll click select all. The only thing we want is roll, and go apply. So this is roll from the bare hull. And then what we want to do is go select data. And then we're going to add a new series here. So we'll call this roll fins. Nope. Degree for the label. I'll pick the series values. We'll pick the time in the worksheet for fins. Did I do that right? No. Control Shift down, enter. And similarly for the roll values, we just want to do roll only. Click on the top, Control Shift down, and go OK. And then, so we've added a new series. So yeah, that's pretty much it. So now we have a time series of roll from the yacht with the bare hull, and then it's kind of like immediately you see this lower roll behavior with the fins on. Just to make a nice comparison to show kind of like a synthesizing a before and after time series in this John Swap 1.5 meter 7-second wave height. Of course, like later you can get into all the kinds of formatting options that you want in Excel and work with the markers and stuff like that to clean it up and make it look like you want, if you want fewer markers or no markers or whatever. But really, I just wanted to highlight how do you get the data in Excel, and then showing a nice before and after, just to communicate. This might help giving another way to visualize easily and quickly what kind of performance you might get to stakeholders in your ship design project. All right, that's it for now. Thanks for watching.